Hello, my name is Anjali Shukla. Today we are going to cover the topic that is feed-forward neural network. Okay, so let's do further. First of all, we are going to see overview what we are going to cover today. That is what is neural network, types of neural networks, then feed-forward neural network, perceptron, single layer perceptron, multi-layer perceptron, delta rule, how does a feed-forward neural network works, example of feed-forward neural network, then application of feed-forward neural networks, advantages and disadvantages, back propagation, and conclusion and reference. So let's move further. First of all, what is neural network? So as we all know that artificial neural network is playing a very important role in we can say in the artificial intelligence, in the machine learning, because as we all know that it is the name only suggesting is a neural network. So it is working on our human nervous system, based on our human nervous system. So how our human nervous system is connected with the nodes, like that only it is connected with the nodes. First of all, it is having input layer, then hidden layer, then the output layer. What is input layer is doing? It is taking the input. Hidden layer is the processing place where the data is processed. It can have a one or more than one or many hidden layers. If we are having many hidden layers, then the accuracy is increased. Then comes to the output layer. Output layer will give you the desired output which we want, which we expect. Okay, so that is the neural network. Then comes to how it is working. So how it works, the basic idea behind a neural network is simulation, right? So as we all know that the our brain cells are interconnected with each other in the form of nodes, as I have said. So we can use it in the types of project where the recognizing patterns are there, like as we do the projects like handwritten digit recognition, or many types of like a pattern recognition, image recognition. We can use this neural network in the fields where we want to recognize something, right? Because the accuracy matters a lot in any type of projects, and it is providing you the accuracy. So that's the reason people are taking use of this neural network to get the output in the form of proper accurate output. Like in the project we want 95, 98%, 92% of accuracy. So it is provided by neural network also. What is neural network used for? So neural network are a set of algorithm which is as I have said, it is used to recognize, right? So it is used for recognizing the patterns, the clustering. Clustering means grouping of the data, labeling of the data. Then in the types of algorithms it is used. So these are the places where it is being used. Then next comes to the, here we are coming to the types of neural network. So what are the types of neural network? I have seen that there are 6 types of neural networks. First is feed-forward neural network, then comes to the radial basis function neural network, coherent self-organizing neural network, recurrent neural network, convolutional neural network, then modular neural network. So the first one is feed forward neural network. What is this feed forward neural network? We will see in short manner all these things, and we are going to detail about the feed forward neural network. So this neural network is one of the simplest form of ANN. Why it is simplest form of ANN? As the name only suggesting, the feed forward neural network. So if it will go from node 1 to node 2, so it will not come back, it will go on forwarding way, as the name only is telling, feed forward. So it will forward and forward, it will not come back if any error comes. So this is the simplest form of ANN, where the data or input travels in only one direction. Then second is the radial basis function, right? So what is radial basis function neural network? This is a basic function which consider the distance of a point with respect to center, right? It will take the center and the last point, and it will make the distance, and at that type it will make the conclusion what output we will get. Then comes to the coherent self-organizing neural network. The objective of coherent map is to input vectors of arbitrary dimension to discrete map comprised of neurons. So if we will come to the coherent self organizing, we will learn that in brief. Then fourth is recurrent neural network, RNN. We all know RNN. We have seen many times RNN in our projects. So a recurrent neural network works on the principle of saving the output of a layer and feeding this back to the input to help in predicting the outcome of the layer. Then is the convolutional neural network. We use convolutional neural network at many places. In many projects, convolutional neural network is being used, like if we want to do the picture prediction, or if we want to do the face prediction, face recognition, at that type of places we use the CNN. So it is a similar feed to the forward neural network, feed forward neural network, where the neurons have learnable weights and biases. Then last one is modular neural network. Modular neural network is a collection of different networks working independently, right, and contributing towards the output. So here we all can see that they all are different, but they are working somewhere. It is working with the connecting nodes, right. It will take input, it will process in the form of nodes, and it will give the output. So working process is almost same, right. Then next comes to the feed forward neural network. What is feed forward neural network? So this is a type of neural network. It is specific type of early artificial neural network. Early, why? Because it is first, means basic and first. So that's the reason it is feed forward neural network. It is having a very simplicity of design, as you can see in the diagram. So it is taking inputs in the x1, xp, xpi format. Then it will carry weight. Then it will process it, and in the y it is giving you the output, right. So information always travels in one direction. If you got error somewhere, so you can't come back. So it is having, for that also it is having a delta rule, which will remove the errors and which will work on the errors. So no need to come back and work on errors. It will immediately work on errors and remove it, so that there will be no problem for solution for getting the output. Then a feed forward neural network is biologically inspired classification algorithm. So what is biologically inspired? So as I have said that biological, as it is connected from our human nervous system, so that's the reason it is said to be a biologically inspired classification algorithm. Then it consists of possibly large number of simple neuron like processing units organized in layers. Why it is organized in layers? Because as I have said, the more will be the layers, the more will be the accuracy. So for getting more accuracy, they are organized in layers. Then comes to the next slide, that is single layer and multi-layer perceptron. So first of all, what is perceptron? Perceptron is a neural network is interconnected system of perceptron. So it is safe to say perceptrons are foundation of any neural network. So without perceptron, we can't make any neural network, right? So they need perceptron. So we are having two types of perceptron. First is single layer perceptron, and second is the multi-layer perceptron. So we will see what is single layer perceptron. Single layer perceptron is having an input layer and output layer neurons, as you can see in the diagram. So feed forward neural network is commonly seen its simplest form, single layer perceptron. Why in the simplest form? Is because it is not having many layers, right? So output is values in the -1. So if the sum of values is above a specific threshold, usually is set at 0, then the value produced is often 1, whereas sum falls below the threshold value of output -1, right. So it is very simple because it is giving values in the form of 0, 1 or -1. So it is in the binary format. That's the reason it is very simple. Comes to the multi-layered perceptron. So what is multi-layer perceptron? Is it's quite deep in the artificial neural network because it is having more than one perceptron, right. As I have said, in the single layer it is having a single layer perceptron, but in this it is having more than one perceptron. That's the reason it is quite deep, right? So it is composed of many hidden layers, and as you can see, it is having here 2 hidden layers. So it is more the hidden layers will be there, the accuracy is very exact, but the process is quite difficult. So that's the reason why multi-layer perceptron is being used. Then comes to delta rule. What is delta rule? As I have told, the delta rule is key behind the delta rule is to use gradient descent to search the hypothesis space of possible weight vectors. This is quite means like easy to understand, is like delta rule is something that is using gradient descent to find out the errors, right? So if your process, or if your whatever you are working for, or whatever topic would be there, if errors would be less, the accuracy would be there. So that's the reason why in the machine learning and AI networks, people are using delta rule to find the errors and to decrease the errors. Comes to the how does feed forward neural network works. Feed forward neural network is working like on the input, hidden as well as output layers. It can have single as well as multiple layers. So that is how it is working. It is working from nodes to nodes, and it will give you the output. Then example of feed forward neural network. So examples are like you can see in the diagram. So the blue point belongs to one group and the orange point belong to another groups, right? So it is having its formation of groups and nodes, and it is working on the training as well as the it will fix one training data and testing data, and by that process it will work. This is the example, this is the diagram. You can see the left image is showing you the example of data linearly separable. As linear, we know the data is very clearly mentioned, so that is a linearly separable. On the other hand, the image of right showing is the example of data which is not linearly separable, right? So it is quite dismissed. Then comes to application of feed forward neural network. Applications are various. We can use many places this feed forward neural networks, and in the left side diagram you can see the human nervous system, and in the right side diagram you can see the artificial neural network, as it is also connected with the axon as a node, and it is also connected in the hidden layer with the nodes. So you can use it on the larger ways, on the very various types of machine learning applications, as well as if you're working individually, you can perform it in any projects, and you can take use of this feed forward neural networks. Then the advantages and disadvantages, they are very disadvantages are very less, because it is having a high accuracy, noise tolerance, ease of maintenance, then independency, then can be implemented in parallel hardware. Then many more advantages are there, and the disadvantages are maybe the transparency is not there, as it is working on the black background, and trial and error design is some of the this comes in the disadvantages. Data hungry, sometimes overfitting, and it is totally dependent on quality and amount of data variable. It can't be a disadvantage, but yeah, it comes under disadvantage. Then comes to back propagation. Propagation is one of the very important topic in feed forward neural network, because it is providing you to go back and resolve your errors, right? So if I take example, so here you can see, here it is the input layer, right? So if you are having an input layer in the form of x, and it is carrying some weight with it, any type of weight, and you are having some desired output, desired values, like if I say 0.123, right? We are having this desired output, right? And we are following the process of hidden layers. We are having a multiple hidden layers processing, multiple processing, but at the end, during the whole process, we followed very proper steps, but after that, after the completion, it is not giving you the desired output, the exact desired output. You can say you are getting output in the form of 0. Something 111, you're not getting 0.123. So what you can do in back propagation, you can go back, you can change the number of your weights or whatever numbers you are carrying, you can change the numbers and you can resolve your errors, right? So this is the advantage of back propagation you can do in the feed forward neural network, or you can say in the neural network. You can go back, you can resolve your error, and then you can error not, or you can resolve your numberings and you can come back with the exact output what you have expected. Then finally, this is the conclusion, and these are the references what I have taken to build this PPT for all. So thank you. This is all from my side.